Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Know-How is brought to you by Cashfly.
Today on Know-How,
we're gonna funk up your Funko Pop.
welcome to Know-How. It's a Twitch show where we build, bend, break, and put on our safety glasses. I am Father Robert Palliser.
I'm Megan Maroney.
And for the next however many minutes it takes, we're going to be giving you the knowledge you need to turn your Funko Pop into a Funky Pop. Is that about right?
Yeah, we should say what Funko Pops are.
You're big into them. I mean, everyone has seen them, but you are an actual collector of Funko Pops.
I'm a collector of female Funko Pops. When I first, female superhero Funko Pops.
Got it.
And when I first started collecting them, there weren't that many, but now they make more. So this is Rose.
You've got Rose, you've got Jayla and Uhura from Star Trek. You've got a Ghostbuster. You've got Etheria. Is it Etheria?
From Wonder Woman?
From Wonder Woman, right. And, of course, you've got the Guardians of the Galaxy, my personal favorite. If you go to my overhead here, that's Gamora. And this is the little thing that we're going to be creating. This is actually an Arduino-driven stand. Now, you were complaining that although you like the Funko Pops, not all of them come with stands. Like Princess Leia has a stand, that back row has a stand, but most of them are just standalones, and you shake the table at all, and they tend to fall over.
Yeah, they fall over, and you see me at my desk constantly trying to set them back up. Like Joyce from Stranger Things, you forgot to mention her. That's her there.
I haven't seen that yet. Does that make me a bad person?
Yes, it does, but we'll ignore it for the next half hour. After that,
all bets are off.
All bets are off. Yeah. But so, yeah, I just have some stick-em on Joyce's feet to have her stick there, and that's not good.
Right. So you gave me a challenge a while back. You said, look, I want a stand, so something that's going to hold them up, something that's going to look good, and you thought, hey, you know, as long as it's a maker project, why don't we jazz it up a little bit, funky it up a bit.
Funk it up.
Right. So we're doing a standard WS2812 project. It's an Arduino-driven ring of LED lights. You've seen the code before. We've just slightly modified it so that there's a bit more flexibility, a bit more controllability. But the other part of this, if you go to my overhead, is inside of here, there's actually a magnet. So what we can do is we're going to be able to attach little iron or ferrous material slabs to the bottom of your character's feet, and they'll be able to stick magnetically. Now, the cool thing about that is you'll be able to move them very easily. You just kind of tilt them to the side and remove them from the magnet, but it'll also allow you to keep them nice and solid, so that even when the table shakes, your Funko Pops won't become dead pops? Tilted pops? I don't know what we call these things.
They don't die when they fall over. They're superheroes.
Got it. Got it. All right. Now, since this is a soldering project, and since both Megan and I will be soldering these, I do have to admit that I've cheated a tiny bit. If you go to my overhead cam again, I've pre-soldered some of the components. Like these are the momentary switches that we're going to be using. I've also pre-soldered the resistor that we need in order to make these things work properly. That's just because, well, we don't have 2 hours to put everything through its paces on camera. But you've seen us do this before, so you understand how this works. And I'll actually explain how these switches are connected. Now, Megan, very important, before you solder, you have to think safety, right?
Safety first. Is this time now?
Yeah.
If you're only listening and you hear this rustling, that's me opening my safety goggles.
See, now I gave you the sealed package because, you know, I wanted to make sure you knew that I wasn't giving you some used goggles. I've got my old Google glasses. By the way, if you ever go to a maker fair, just grab a handful of these things. Seriously, they understand you're going to do that, and they're always useful. That looks good on you.
Thank you. I think so, too.
Yeah, and we, you know, yellow, green.
Yeah, they're from Google. They were free from Google. They're probably recording our conversations and our thoughts right now.
And they will be sending us an invoice for all of them that we took. Okay, so go ahead and turn on your soldering iron. It's the second switch over here. No, other side, other side. Right, there you go. Okay, so they've both been set for 385, which is fine. I gave you a blunt tip, which will make it a little easier for you to work with. I'm working with the sharp tip.
Oh, wait, so what's this?
Oh, that's a heat gun. You're not going to be using that for this particular exercise.
I'm just using this.
Yeah, yeah. So, and be careful with that. It actually is heating up. Now, you've done a little bit of soldering before, but I just remind you that You always want to apply the solder to the joint, not to the iron, although you could put a tiny bit on the iron just to sort of prime it. And then every time you're done, you put it into the slag pit, give it a couple of brushes, a couple of pokes, just to get it nice and clean.
Got it.
Cool? All right. Now, I want to start you on the project so that you have as much time to complete it as possible. I'm going to go ahead and disconnect our little prototype here. Let me show you what's actually inside here. Now, the prototype model is not as good as the finished versions because it's prototype, and a lot of this was sort of just slapped together. But inside here, all of this is a diffuser. So this is clear PLA material with the magnet in the middle. Now, it's hot glued. My original design was I wanted to make it super, super tight just by pushing it in there. But then I realized if we did that, there'd be no way to remove it unless you destroy the piece. So it's just hot glued. You can strip off the hot glue, remove the magnet, but that gives us this nice little ferrous surface. Oh, and by the way, this also works if you ever wanted to make one of those little sculptures where you have a bunch of iron pieces. This actually will work for that.
Oh, that's
which
smart.
is kind of cool. Now, inside, this is where the magic is. So we've got our WS2812 ring, this 16 LED ring, and it's connected to the base here. Now, the base has this piece. This piece is what holds that ring. It's screwed into the bottom here with two 3mm screws. It's got a place for you to put your Arduino. So the Arduino is actually slotted into that, like so. Oh, like if I push really hard, I will break it. Actually, I need to shave down this Arduino a little bit. There we go. And then it's got a hold-down bar that I've constructed here. Oh, there we go. Which just pushes in on those two little, you see those two empty holes there? So it's just friction, but this will hold the Arduino into the case so it won't move anywhere. And then I've also got these little stops. So once we put the buttons into the button receptacles, these little pieces, which will break off this backing, they just keep them from moving out. So it's a super simple design. I'll actually show you what went into the 3D design. I'll show you a little bit about the code. But Megan, what do you say we get you kicked off?
Okay.
Okay, so the first thing you're going to want to do is we are going to be soldering the switches to our Arduino. So let's go and get your Arduino situated in there. Take that out. You're going to want to clip it into your helping hands.
Which side?
Well, okay, so actually go to the diagram there that we've got, Alex. This is what it's ultimately going to look like. You've got 3 wires coming off that button, a black, a red, and a white. So the ones we're going to want to solder first are the whites. So button 1 is going to go into D6, and button 2 is going to go into D7. Do you see the lettering and the numbering on the Arduino itself?
I might have to remove my safety glasses.
Digital 6 and digital 7.
Yeah, it's upside down.
That's fine.
Yes, digital 6 and digital 7.
There you go. And the way that we're going to solder it is we want to solder so that the wires are sticking up out of the top of the Arduino.
Okay.
And the solder joints will be on the bottom.
Okay.
So we want the wires going in like so, like that. And then they're going to be soldered to the bottom.
Okay.
Okay. So take one of your switches first.
Either, does it matter which one?
Doesn't matter which one.
Okay.
One of them is going to be button 1. One of them is going to be button 2.
Okay.
Okay. So I haven't stripped these for you yet. So we've got a nice little pair of wire strippers that you can use. And the way that you use this is you use it to break just the insulation. You can't crank down too much and then pull the rest. So start with the white. But what I can also do is just use your fingernails. Well, you probably won't because you've got nice fingernails.
I do.
But this is small enough gauge wire if you go to my overhead. Or I can just do this and strip it away. And now I've got just a little bit of exposed wire.
So I want to be able to see the wire.
Well, just you don't even have to cut. As long as you're gripping a little bit, you should be able to pull the wire through. Okay. While you're working on that, this is what's called tinning. So we always tin our wires before we install them, just because it makes it a little easier. If you go ahead and go to my overhead, here you go. Ta-da! And I'm going to apply a little bit to the iron just to make sure it's hot. Good. There we go. It gives me a nice, clean joint when I put it into the Arduino. How you doing over there?
I'm having some troubles, but I think I got it.
Here, you know what? Let me use my fingernails because I am a horrible fingernail person.
Called for a lifeline already.
Well, no. It's just it can be a little nerve-wracking because you kind of have to have a feel for wire strippers. I should get all three of yours.
Did you already do it?
Yeah. Oh. Well, that's because I don't care about my fingernails. Because I am a nasty.
So rule number one: don't get a manicure right before.
Don't get a manicure right before.
Try to strip wires.
Right. But so let me give you that. The other, if you give me the wire strippers, what I'll show you is how this is supposed to work. All you have to do is grip it a little bit. You don't actually have to cut. You just have to hold it. If you hold it enough and then pull.
Oh, I see.
There you go. See?
Got it. All right. Now.
So go ahead and you want to tin that first. So put it into.
So I assume this is already hot.
That's hot, right? So put it into one of the other helping hands.
Oh.
Yeah, you got four of them.
Put the
wire
in, not
right? Because you're going to tin it. So what you want is you're going to tin the exposed part. Well, no, the wire itself. There you go.
Oh, so I don't have to hold it.
Correct.
Should I put it under the
anywhere that it makes sense for you to put it. You know, you need to be able to reach it. There you go. Okay, so you're going to take the soldering iron.
Okay.
And you want to apply heat to the wire, and then when the wire's hot enough, go ahead and take this solder and just apply it to it, and it's going to melt. You'll see a little puff of smoke, and then the solder will go into the wire itself.
So I touch the wire
hold
first?
this with the other hand. Yeah. So touch it.
Heavy.
Touch it with the wire. Touch it the iron to the wire. There you go.
Remember last time I didn't have my elbow down.
Right.
That was. Should it be melting a little bit?
No. Now touch the soldering, the solder too. No. So touch. So you want to heat the wire and then touch the solder to the wire, but you have to keep heating the wire.
Oh.
Yeah. There you go. There you go.
Ah.
Yeah, that's good. That's good. All right.
Takes a very steady hand.
It takes a steady hand. See, that's why the helping hands are there, so it can hold it exactly where you need it to be. Which this wouldn't work. There you go. That should be enough. This wouldn't work if you were trying to do everything without the helping hands because you're using both of your hands right now. So who's holding the wire?
So that should be enough. Now I put this back in the ashtray.
That's actually, it's a bit much. Let me get some of that solder.
Burke, you're making me nervous by watching me.
There you go.
I brought you some better wire strippers.
All right. All right, here we go. And now.
Okay. Yeah, no one's watching me, right?
Okay, so we're going to go ahead and put this first wire into our Arduino. So go ahead and take the wire you just soldered.
Off of the helping hand?
Off the helping hands. You're going to put it through D6, which is digital 6. Right there for me. There you go. Okay. Push it all the way through. Okay, good. Now what we need to do is we need to flip it over, which will be easy for you. You're just going to turn that around, and you're going to want to pull it back just enough. Oh, see, you have to be careful. This is where you can use the other hand. So use the other hand to hold the wire, so the wire will stay where you want it to be.
There's a lot of helping hands here.
So it's
never enough.
It's a little dance. You gotta coordinate the helping hands and the wire itself. So if you go back to my my overhead, Alex, what I'm going to do is I'm going to pull this back until it's just the wire. So I don't want any of the insulation. And once I've got that, I can use my helping hand to sort of lock it in. Like so. Now that's what I'm going to solder. So I'm gonna go ahead and do this really quickly, and then I can help you with yours. If I need that. And when we do this, we want to heat up the wire and the through hole, not really the solder. You don't want to put too much heat, though, because otherwise you're going to cause issues for your other components on the board. There you go. Okay, so how you doing over there?
Well, it feels like I might have closed up the hole with something. It's not as easy to get through. Is it through?
Yes.
Okay. All right. Now I turn it over.
All right. Moment of truth.
Okay, and now I touch it, the wire first?
You're gonna no. You want to touch it to the D6 slot. You see the D where you just put it through?
Yes.
Okay, so you want to heat up that through hole, and then you're going to apply the solder to it. But remember, you kind of have to keep the heat on it. If you remove the soldering iron, it will immediately start to cool, and very quickly it gets too cool to apply solder.
Okay, say that again. I touch this to the
Not your hand. You don't want to touch your hand. It will get the bacon smell.
Okay, so I touch it to the hole.
Okay, wait here. Hold on. Put your iron away for a second. I'll show you again.
Okay.
I've just removed mine. Okay, so here's what I've done. I've pulled it back so just the insulation is showing. Mm-hmm. And then I'm going to take my iron, and what I'm going to do is I'm not going to heat up the solder. I'm going to heat up the through hole and the wire. I need to get that hot enough to melt the solder. And the reason why I'm doing that rather than heating up the solder is because if I just put a blob of solder, it's not necessarily a good connection. I need a good connection here. So see how I'm touching the wire and the through hole? Mm-hmm. Just a little bit of dab of solder. And I'm good.
But how do I hold the solder and make sure this is still in the Arduino?
That's what the helping hands are for. So the helping hands should hold everything except the...
Do you have my solder?
I do.
You have the solder? Okay.
Here you go.
So the helping hand should hold everything except what?
Well, except the solder and the soldering iron. So you need your hands free. So everything else needs to be maintained by your helping hands. That's why I give you the nice one.
But how can I keep this? Because it keeps... Okay, it doesn't keep falling out.
Right.
Got it.
Well, you just have to adjust the hands until it stays exactly where you want them.
Okay. Okay.
Okay? All right, here we go. Moment of truth. Remember, Megan is a novice soldering person, so...
Really? That wasn't obvious.
This is a major accomplishment.
Okay. So... It keeps coming out. I don't understand how you keep it in the hole.
Yeah. Actually, here's what I'm going to do. I'm going to set you up with a quick cheat. I'm actually going to preset this for you. So the problem is you're trying to use the helping hands to hold the wire, but they won't hold it as long as it's up here. So take this out, put it down below. And now I can put this into slot 6. Like so, digital 6. Okay. Now I'm going to have one helping hand hold the Arduino, like so. Oh, come on. Oh, that's the wrong one. And the other helping hand is going to hold the wire, but it's going to hold it in the right position. Like so. And there you are.
Okay.
And that's the other nice thing about having a good set of helping hands, because once you get it into position, you can spend as much time as you need with the iron to get the wire soldered in properly. Okay. So while Megan's working on that, I want to show you some of the 3D design that went into creating this. If you go ahead and go back to my my computer in just a second, because it reset and it logged me back out of Tinkercad. This was all created in Tinkercad, which is the software that I've been suggesting to people because it's free, it's online. Essentially, if you have a browser, you can use it. But I use some common elements that you may have seen on previous know-how projects. I'm loading it up right now. This, if you come back, there we go. This is the Funko Pop project. So as you can see, there are 1, 2, 3, 4, 5. There are 5 elements to this. It started with this. This is the diffuser. And all I did was I used a micrometer to measure how big the Funko Pop dolls were on average across. So this is the perfect stage for holding one of them. This centerpiece is perfectly sized for the magnet. So that's what the magnet is going to go into right before I hot glue it. Then this, you may notice this. This is sort of a flattened piece of the diffuser, and then you've got this little mounting hole. This is so that there's only one way to put it in, because it's a perfect circle except for that piece. So if you try to push this diffuser in the wrong place, it actually won't slide into its receptacle. And then that little hole is so that the mounting screw can bolt it. Now, this is the LED shelf. I've actually reused this. This was used in Scully. So if you did our Halloween project, Scully, this is the same shelf that held down that WS2812 ring. This is the hold down that's been designed to fit into the receptacle down here. Now, this is really just a place to hold an Arduino, hold the WS2812 rings, hold the 2 buttons that we're going to be making, and then you'll notice there's this little sort of shelf around the inside. That's because that won't allow the diffuser to go down any further than it should, which means it will be completely flush up top. And the last bit of this are these 2 holes at the bottom. They're there because if we ever want to open this thing back up, we need to poke something through there to push the diffuser back up because it's a very tight fit. Megan, how you doing?
I think I made a mess.
You made a mess. Okay, what happened?
There's too much solder on there. It's like a big blob. See?
Yeah. Okay, so this is actually very common. If you pass it over to me. Okay. There we go. There we can show people what it looks like and how to fix it. This is incredibly common, especially when you're first starting. You tend to want to put a lot of solder. If you go to my camera, this is what it looks like right now. So Megan's got it in the right pin. It's in digital 6, but at issue is the fact that there's this big blob. Now, it's not actually touching any of the other through holes, so it wouldn't actually be a functional problem, but it's not neat, and we don't know if it's actually a good connection. So I can fix that really quickly, and the way I'm going to fix it is I'm going to use my iron to remove some of the excess. So just like this.
I solder blobbed.
It happens. There you go.
Is there a good connection? Or you won't know until we're done?
Well, that's what I'm doing. So by maintaining heat a little bit, what it's doing is it's actually allowing the solder to flow into the wire itself. And then I'm just going to use these diagonal cutters to cut off the excess. There you go. That should work. Good job.
Thanks.
Okay. Now what we need to do is we need to repeat that process for the next one.
Okay.
So you've got the second button, and you're going to go ahead and try to do the same thing. Now, while you're doing that, I'm going to go ahead and do the same for mine.
So the white in D7.
The first white one in D7, right? Oh, yes. So you've got the last one in D6. This next one goes into D7. And I'm going to do the same. I love your magnifying glass. That always looks so good. Mm-hmm. I need a little bit of solder on my side.
A little bit of a reflection in there, but...
Now, your son came to, or one of your sons, came to Maker Faire as well. Huck was really into trains. Is that sort of his thing?
That's his thing, yeah. Model trains, the big train, the steam engine, yep.
Oh, he loved the little actual steam-driven ones, not electric.
One twin is into trains, the other one is into space.
Space trains.
Says everything you need to know about each of them.
But does it really?
Yeah, things that are on a track and go a certain way versus things that just get shot into space and who knows where they go.
Okay, so I've gone ahead and stripped my second one. Do you want to try using the wire strippers again?
Oh, I forgot about the stripping.
Yeah.
Well, Burke was kind enough to bring me some better wire strippers. Here they are.
Well, he thinks they're better.
Don't pick them up by the blade, folks.
See, Burke says it's better, but it's already hurt you more than my tools. In fact, I think that's what Burke wanted. Mm-hmm. Burke's always trying to hurt us. It's weird.
I think these are for bigger wires.
I think so, too. I love Burke, and I think he tried to help you, but I think he's just going to hinder you. Okay, so I'm going to do the same thing. I'm applying heat to the wire and to the junction, not to the solder itself. Ta-da! All right, so while you're working on that, I'm going to work on the next part of the process because the buttons are really the hardest part of this project because without the buttons, we don't have control over the animation or the brightness. In order for a button to work on an Arduino, you actually do need to have 3 wires. You might think just 2 because you just have to complete a switch, but that's not how it works on an Arduino because the Arduino, the pins, the digital pins, they're not measuring on or off. They're actually measuring a digital value. And if you have no current flowing through a connection, there actually is no value. It's just free floating. That's why if you've ever tried to directly hook up a button to an Arduino and you've looked at the input, it will fluctuate. You'll get 0, 1, 1, 1, 0, 0, 0, 1, even though you're not touching anything. So what we need when we're hooking up a switch in an Arduino is we need a way to maintain some form of current that the Arduino can then differentiate between on or off, you know, a closed circuit or an open circuit. The way we're going to do that is by using a resistor. So this circuit, when it is open, so when I'm not pushing the button, still has a current because on the same pole as the digital input, the digital switch, I've got the ground wire. But more importantly, I've got the ground wire with a resistor. And what that resistor is going to allow me to do is it's going to allow me to have a very minimal amount of current flowing through it. Then when I push the button, it's going to short the circuit, and I have a lot of current flowing through it. And that's what it's going to register, between a little current and a lot of current. But if I try to hook it straight without a resistor, all that's going to happen is I'm going to have either a short circuit or a short circuit, which, of course, that will do jack. All right, Megan, how you doing over there?
I stripped the wire so it looks like a broom.
Okay, see, that's a problem. You want to twist those together.
Okay.
Yeah, because if it's spread out like that, it's going to be almost impossible to get it into the through hole.
I'm having flashbacks to sewing class, which I wasn't very good at either.
That's okay. Sewing's good for you, Megan. It's good for the soul. That's what my mom kept telling me. All right. And actually, I soldered the wrong switch.
Oh, no.
Yeah.
I had incompetence is rubbing off on you.
I know. I pre-soldered a bunch of stuff, and I just soldered in something I didn't pre-solder, which is fine, because now I can show you how I do resistors. All right, here we go. So I was supposed to solder this one, because this already had the resistor. By the way, this is a 10K resistor. Instead, I'm going to go ahead and connect it now, because that's how I roll. Now, if you go back to the diagram, Alex, this is going to show you how it works. So I've got the white leads going to digital 6 and digital 7. The red leads, that's just 5 volts. So that doesn't matter. I can have them going back to a common line. Now, you'll notice on the black line, so the ground lines, I've got a common coming up from the ground pin on the digital input side of the Arduino, going into 2 separate resistors. I need 2 separate resistors. If I try to use one, it won't work. And then each of those is soldered to the switch. So I'm going to go from, on one side, the 10K resistor and the digital output, and on the other side to 5 volts. Hopefully that makes sense. I know Megan's not paying attention to that, but she doesn't have to.
No, you're getting way ahead of me.
Yeah. No worries. No
Wire
worries.
first or solder first? And what's all over my soldering iron?
It's probably just a little excess solder.
How do I get it off, or I don't need to?
No, you don't really have to.
Okay. So do you have the solder over there? Or do
I do.
I have it here?
Here you go.
Okay.
All for you.
Wire first or solder first?
Yeah. So you apply the heat to the junction between the wire and the. There you go.
Just a little there.
Well, I mean, it has to be consistent contact. Otherwise, it's not going to heat up. There you go. And then the solder. No, well, no, you touch the solder to the joint. There you go.
I think I'm not getting just the total concept of this.
So you need to create a solid joint between the wire and that junction. So that's where the solder has to go. But you have to have heat. So if you just tap it, it's not actually going to heat it up. Good?
I think so, yeah.
Okay. Yeah, see? That's what we like. A little smoke and solder.
And I always want to overdo it.
Yeah, I know. That's a very common mistake when we're new at this. All right, if you come back to my camera, so this is what I'm doing. I am actually soldering the wire to my 10K resistor. I've got it wound around there. And I'm going to heat up. Actually, this would be good for you, Megan. So what I'm going to do is I'm going to heat up this junction. So I'm not heating up the solder. I'm heating up the junction. When the junction is hot enough, that's when I'll do this. And the solder just sort of flows. That's one side.
Oh.
Want to give that a go?
Oh.
Well, on your wire.
Yeah.
Same principles. All right, so I need to do it for the other side. And luckily, I always bring wire.
Uh-oh. But
So,
I have more stripped wire underneath.
so it's a little. Yeah, you kind of want the conductor. You want the insulation to go all the way up because otherwise, if the wire moves around, you might actually short with something.
So I didn't do that. Now what do I do?
You can heat it up. You can heat it up and then just push it through. So that solder, when you heat it up, becomes like a fluid. You can just push a little bit more and get it back in there. Does that make sense? Kind of, a little bit. No, not at all.
So the wire. This is such a mess. Take a look at this, Alex. Look what I've done here. Oh, you can't.
There you go.
Yeah, you can't actually see how bad I've done here.
You know what? This is a learning experience, Megan, and all
Right.
of these parts are really
You create
inexpensive.
two, and you mess up on one,
Right.
and yours is going to look awesome. So can I? Okay, now help me, Obi-Wan.
Okay, what do you need?
How do I push this wire through?
Okay, sure. Actually, here, pass it over, and I'll show you. Because trust me, this will not be the last time you ever have to do this.
Okay.
So I'm going to use the helping hands to make sure that the wire doesn't slip out when I heat up. So this is what Megan's talking about. She's got all this wire underneath that shouldn't be there. We should have almost insulation to right up to the Arduino. So I'm going to heat this up just to make this liquid and then push through.
Oh.
See?
Wait, what did you heat up underneath or at the top?
The top. So I
to
just
make
heated
it liquid again.
Right. I just heated up the wire enough so that actually you've got a strand here I want to get rid of before it makes contact with anything else. There we go. I just heated it up enough to flow the solder, and once the solder was flowing, I just pushed the rest of the wire through like so.
Okay.
All the way up to the insulation. And then actually, that's pretty good, Megan. That's nice and clean.
Actually.
That's clean. No, seriously, that's a clean joint.
Because you did it.
There we go. Ta-da! Okay, and so what I want you to do is see all that excess. You're going to take this diagonal clipper. You're going to get as close as you can to the surface, not all the way down, but cut it because you don't want to leave any excess. This is, hey, you know what, Megan? You're doing fantastic. For a person who does not solder on a regular basis, you're doing great. Thank you. Get her on this. Hey, get in there. Da-da-da-da. See, doesn't that feel better? Now it seems neat, right?
Look at how pretty that is.
Yeah.
Look at that.
Congratulations. Good job.
We're done, right?
Yeah. Okay. Thank you very much for joining us. We hope you've enjoyed our Funko Pop, but we have to go now. If you can give me those clippers really quickly. I just want to show them this. So this is what this looks like. I cannot leave it like that. You wanted to know what that other attachment was for. It is for heat shrink. So what I'm going to do is I'm going to apply some heat shrink onto this thing so that it doesn't ever come into contact with something that will cause a short, because that would be a bad thing. So all I have to do is take a little bit of heat shrink. I'm going to slip it over like so. This is going to cover both the wire and the resistor. Ta-ta-ta-ta-ta. And once it has that, let me get this out of position. I'm just going to use my heat gun to shrink it down. Like so. So this is a heat sensitive material. So when I heat it up like that, it just shrinks down, and now it's one solid connection. All right. So next step, let's go ahead and get the red wires connected.
Okay.
So if you stay on me, on my my overhead, there we go. These are common, so I can just do this. I'm going to strip them like so. I'm going to twist them together. And I want this as neat as possible because this still has to make it through one of the through holes.
So you strip both the red ones?
Strip both the red ones, twist them together so it looks something like this. And then I'm going to go ahead and solder these. I'm going to tin it so that it'll make it a little easier for me to get into the through hole. Like so. Ta-da! Something else, and this happens to me too. Sometimes you feel a little desire to do other things while you're still holding the soldering iron. You need to fight that desire. Anytime you need to work with your hands and you're not soldering, the soldering iron should be back here. Because otherwise you'll do, you see the burn marks on your mat? Mm-hmm. That's when Brian was trying to work with his hands and a soldering iron at the same time.
But did he not have a little tray? Why didn't he just use the tray?
Yeah, because we have a temptation to think, that's cool, I can hold the soldering iron and do this. All right. So now I've got my through hole. I'm going to do the same thing for the black wires. Because the black wires, now that I've got my 2 resistors on there, they're common. So I'm going to strip. Strip. By the way, this thing with the fingernails, that really only works because I'm using 30 gauge wire. It's super, super skinny.
Yeah, I figured out how to do it with my fingernails. That was easier than
using the strippers. Okay, so same thing. So if you watch, I've put them together so they make basically one connector, and you really have to twist these together because if they bunch out at all, it's they're not going to be able to go through the through hole. Then notice how I'm heating up the wire. And I'm maintaining constant contact. So I'm not just tapping it. I have to stay on it until it's hot enough to melt. There you go. That's my red and my black. So I'm going to hook this up to the 5-volt and the ground of my Arduino, and that should be my switching system. I should now have the ability to send commands to the Arduino from the buttons. All right. How are you doing over there?
So I put the 2 red ones together, and then do you solder them together?
Right, just a little bit. So you just want to flow them together enough.
Solder?
Oh, yeah, of course. Here you go. Okay. While you do that, I'm going to go ahead and move on to the next step. So I'm going to take this, and I'm going to put it through the ground hole, the ground through hole right there. And this is why it's important that you stay really neat, because if you've got any excess solder, it will not make it through this hole. This is actually a very small hole. Like so. Ta-da! All right, so I'm going to use my helping hands. This one's going to hold the Arduino. This one's going to hold the wire. My helping hands are kind of falling apart. They're not so much helping hands anymore. It's a helping hand. But you know what? I've had this thing forever, so there we go. All right, so I've got this. Same thing. I want to heat up the through hole, not the solder. You'll notice every once in a while it looks like I'm tapping the solder to the iron. That's just because I want to make a little bridge. If you have a tiny bit of solder on the iron, the interface between the iron, the hole, and the wire, heat will transfer more quickly. But I'm not melting the solder and then putting it on there. Oh, my helping hand is not helping. It's falling over. It's a falling hand. There you go.
So the red and the red and the black and the black.
Red and the red and the black and the black.
And then, but did you put the black to the red? Did you attach the black to the red?
No, no, no. So the black is going to go into the ground, the GND hole.
Okay.
And the red is eventually going to go into either the 5-volt or the VIN, the voltage in hole.
Can I have the solder?
Yes, you can. Actually, that you might have trouble getting that through, but you can just clip it.
Okay. I know. It's just, I feel like the more solder, the better. That's not true.
Not necessarily.
It's like glue. It's the same. You just put a bunch of glue on there, and you know the thing will stick. It's just like how I podcast. Like the more you talk,
Right?
eventually you'll say something interesting.
I don't think it works like that. I've talked forever, and I still haven't said anything interesting. All right, good. So here's the next part. Alex, if you come on over. I'm going to take the red leads, and I'm going to put it into the 5-volt. I'll actually put it in, the 5-volt hole. And that will just means that the Arduino itself will be supplying 5 volts to my switches, my buttons. There we go. So this one's going to hold the Arduino. This one's going to hold my wire.
Can you remind me again where the red goes and the black goes?
So the black, if you look on the other side of the Arduino, there's on the same side where you've got your white wires, there's a hole that says GND. That's ground. Okay. So it's going to go in there. Okay, and if you come back over, all right, I'm going to go ahead and solder that in. Same thing as before. I'm going to heat up the through hole and the wire, not the solder. And once it's hot enough, it just flows. One other trick that you can use when you're doing this is once you've got a decent joint, you can actually reheat it and let it flow, because the solder will naturally want to flow into places where there is no solder. That's a really good way to make sure that you don't have a cold joint. And a cold joint is just, it means it's a solder joint that looks like it's soldered, but it's actually not. You know, it's just a blob of solder over an empty connection. There you go.
That's sad. That's the saddest thing I've heard.
I know, right? Okay, so I've got my 2 buttons, and they're all jumbled like this because they're going to go into the same place. They're going to go into that enclosure. But this now gives me the ability to change brightness and the animation pattern that's being displayed. Of course, in order for me to do that, I'm going to have to get my WS2812 rings. And while Megan works on hers, let me show you what that looks like. So this is, you've seen these before. We've used these in a lot of our projects. This needs 3 connections: ground, VCC, which is 5 volts, and in, digital in. And that's the going to be from digital pin 3. So what I need are 3 pieces of wire. I'm going to be, not green, I'm going to be using black for ground, red for voltage, and white for my digital input. I made it green just so you wouldn't confuse it with the buttons. But that's what I'm going to be connecting in order to let the Arduino control the light patterns. So while Megan does that, I'm going to go ahead and start connecting this part. Actually, Megan, you're doing exceptionally well. Can I take a look just really quickly? Okay, the problem is you've inserted the wires on the wrong side. You actually want them Oh, wait, hold on.
I did them all wrong?
No. So you want it coming from the top. You're inserting it from the bottom. There you go.
That's what I was doing. This way?
Yeah.
Out. That's what I had it. That's the way I had it.
I thought you had backwards. I'm sorry then. I apologize, Megan. I think I was projecting my own insecurities because I've done that so many times. Is it fitting through? If it's not fitting through, what you can do is use the diagonal cutters to cut away like the blob at the top.
Okay.
Yeah, I've done that too. This is how most of these projects work. You can draw up the schematics. You know it should work. The code should work, but until you've actually assembled it, you don't have any clue if it's actually going to work. All right. And I'll just use these cutters. Like so. All right, so when you're ready for your WS2812 ring, that's the wiring for you. And as we've done on a lot of these projects, what I'm going to do is I'm going to tin the pads first. It makes it easier for me to solder later on. So I want in, VCC, and ground. So that's what I'm going to do. Heat up the pad, not the solder. And then when the pad's hot enough, the solder will just flow. And you really don't need a lot. In fact, you don't want a lot on there. You just want enough so that when you attach the wire will readily stick. And then with all of these wires, what I should be doing is I should be tinning them after I strip and twist them. But I'm not going to do that because we're a little time limited. And, well, I do want to show you this working. Because it fits into the enclosure. We know that with the prototype. But we need to make sure that the electronics are actually going to function properly. And actually, you know what? I lied. I'm going to go ahead and tin these. That's my OCD cropping up.
Mine's not going to be done by the end of the show.
No, that's fine. That's fine. No, but I mean, the whole idea is you're showing them that a person who has very limited experience soldering stuff together, just using the schematics and just taking a look at this episode, you should be able to assemble them one of these relatively easily. We've got the entire parts list for this project, but you don't really need to look at it right now. You can take a look at it in the show notes. It's the same thing that we've done with every Arduino project. The Arduino is going to cost you about $2. The ring is going to cost you about $3. The screws and such will cost a couple of pennies. It's a relatively inexpensive project. There you go.
Should I just cut off some solder so we don't have to share solder?
You can if you want.
I don't like to share.
There you go. Thank you.
Now it's all
And if you could
yours.
give me the diagonal cutters. Thank you. I'm going to cut these down because they're a little bit longer than what I needed. Ta-da! All right, so I'm going to go ahead and solder these to my ring. My black is going to be ground. My red is going to be VCC or 5 volts. And my white is going to be my digital in. See, the nice thing about tinning it is the solder is already there. So all I have to do is reflow it.
Oh, I've done it.
Like so. Oh. So when you get a blob of solder on your iron like that, you want to dip it into the slag pit. Just sort of take that back out. There you go. You show that solder who's boss. Mm-hmm. That's an angry dip. Now, the other thing about this is I actually have one of these that doesn't do a Funko Pop at all. It just holds my water bottle. Because I'm a geek like that. I think I'll leave one on Leo's desk. Because everyone should have an illuminated water bottle, right? I mean, it just makes people happy.
Oh, goodness gracious.
If you're feeling frustrated, it means you're almost there. All right, so I've got my ring connected. Horrible connections, but they are connected. And then if you go back to that schematic, I'm going to show you how I'm going to be connecting this. So it's going to go from black to the ground hole, the ground through hole on the other side of the board, from red to VIN, which is voltage in, which will just give me 5 volts from the Arduino. And then my data line, my white line, is going to go to D3, which is digital 3, which will allow the Arduino to control the entire ring once it's powered up. And do the same thing. I'm going to strip, twist, and tin these. And then it should be a quick connection. And I preloaded the code, so it should work just by powering it up. It's not saying it's going to work, because these are kind of clone Arduinos. And sometimes they don't hold their programming really well. Which, by the way, folks, that's something else to consider. I like to save money because I am a cheap person, so I buy just at Mega stuff. It's Arduino. It's the exact same stuff. But if you want to support the Arduino Foundation, every once in a while, buy a genuine Arduino. You okay?
Yeah. It's not as nice as yours is.
Well, it won't be. It's okay. It's going to work, though. By the time you're...
I don't know. I think I might have burned a hole in the Arduino. Okay, where does the red go?
Okay, the red is going to go into 5V.
Okay.
On the other side, you're going to see 5V. That's just for 5 volts. Yeah, show her the schematic again, Alex. So that's where it's going to go.
Okay.
Okay. Ta-da. All right, let's go ahead and put this in.
Wait, there's a ground on either side.
Correct, correct.
Okay. Does it matter which ground I put it in?
Well, I mean, not really, but I put it on the same side as the button, as the white wires, just because I'm using the other one for the ring. Okay. But ground is ground, so it really doesn't matter which one you connect it to. Okay. So voltage in and my ground. Okay. Yeah, that confuses people every once in a while. They wonder why there's multiples. It's because they know that most people are doing projects like this, which will require multiple ground, multiple voltage lines, and they don't want you to tie everything to the same pin because that just gets messy. Mm-hmm. There you go. All right. Eventually, you get to the point where you know the smell. Mm-hmm. So when you start smelling burning fiberglass, that means you've put too much heat and the board is burning.
I think that one was my favorite.
So you've already smelled that.
I don't know. No, I think I did the 5V. Wish you could see it because it's very nice. There it is.
You're proud of that one.
I'm proud of the 5V.
Nice.
Oh, did it just come out?
No. You're fine. You're fine.
Okay. Oh no, I did it wrong.
Uh-oh. Oh, wrong. Yeah, wrong side. I told you, see? It always happens.
I was so proud of myself.
Oh, no.
Oh, ah!
Oh! Oh, wait, no, okay. Okay, put the iron down, and then figure out what you want to do.
I want to,
that's it, that's that smell.
Yeah.
Welcome to fiberglass world.
Okay, I want to make it liquid again and pull it through.
Right. It's going to get a little bit tricky because once you have solder in there, it's hard to get the wire through again. You have to melt the solder to push the wire through or remove the solder entirely.
I got really cocky.
This, doing maker projects has a way of humbling everybody, especially when you're doing them early in the morning or late at night. All right, there we go. Oh, no, I don't think that's secure. That, my friends, that is a perfect example of a cold solder joint. Looks good, but I can feel it. Yeah. Okay, so this is actually my favorite part. When you get done with a project and you test your connections and you just start clipping off all the excess because you go from messy to neat. So technically, I think this should work and probably not short anything out. But if I connect this, I should have access to my Arduino. And I should be able to program it if I'd like. Although that's not going to happen because for some reason my helping hands kind of messed up the USB port. There you go. Okay. All right, there you go. So this, if you go to my overhead.
Don't go to my overhead.
Okay. So this is the ring, one of these buttons. Like I said, this one controls brightness. So every time I click it, it's going to go up by, I think it's 8% until it gets to the maximum, and then the next click will turn it off. And then this button, actually, let me go to the minimum brightness. There we go. And then this button over here, every time I click that, it's going to change the animation pattern. So this is all loaded in the code, which you will be able to download. And then at the end, what I did was I added a bunch of sort of standard animations that you might want to use for your Funko Pops, like solid colors.
Oh.
I forgot how many animation patterns I put on this thing. There you go. So like red, blue, green, teal, I guess white.
That's
okay.
Nice.
So put all of these under that, and that's how it's going to look.
That's amazing.
All right. So what do we got over there?
I'm on step 1. I can't get I soldered up the hole.
You soldered up the hole?
Yeah.
I can, you know what? Actually, Burke's listening to this, so Burke's going to rescue you with what's called a solder pult.
Want him to rescue me.
Well, he's going to give you a tool
Okay.
that will allow you to pull the solder back out of that hole.
I said
See?
no. Thank you.
Okay, no, this is kind of a cool thing, though. So you, the way it works is you push this down,
Okay.
and then when you push this button, there's a little plunger that's going to suck stuff up. So if you heat up the solder so it's liquid and then hold this right to it, push the button, it will just suck the solder right out of the hole. I know, right? It sounds crazy, but it actually does work.
So I put the thing there, and then
Well, you have to heat it up. You have to heat up the solder so that it's liquid, and
what
then
buttons do I press before I have
this one
heat
right
in
there.
it?
There you go. And then
Did Burke make this?
No.
Okay.
These are common. These
And
are
I
very
trust
common.
it.
Oh, wow. That's no love. All right. So while she's working on that, let me show you how the final assembly for this thing goes. So I'm going to put my Arduino back into my enclosure. It's going to be a little snug because you want it snug because you don't want this thing moving around. That would be actually horrible. Like that. Okay. And I don't even need the hold down because it is so snug, but I'm going to go ahead and use it anyways. And the hold down just goes like this. It fits right over the top. And it is difficult to put it in because it's supposed to be, because the friction is the only thing holding this down. This has no screws, no bolts, no nothing. Actually, I probably should have shaved it a tiny bit just to make it easier. Okay, here we go, Megan. Go. You got this, Megan. Solder pult that thing.
No.
Well, you have to have the soldering iron there at the same time.
Oh.
Because otherwise it's not
It
liquid.
cools off.
It cools off really quickly.
I'm not listening to you, Burke.
Burke's trying to help, though.
You pulled the trigger, though, didn't you? On the solder pole?
Maybe.
I can't hear you.
Oh, fun with Burke. Hey, you know what? I love Burke, okay? I know everyone else in the studio hates Burke, but I love Burke.
Nobody hates Burke.
Everybody loves Burke.
I just don't like when he's right and I'm wrong.
Hey, you know what? Yeah.
Yeah.
Okay. No, I'm with you. I got you. Actually, I'm going to remove the hold down. I don't need it on this one. Okay.
Yes, Alex, it is defective.
Okay, if you come back over. So I'm installing this. So this is the little LED shelf, which will hold the LED ring in the right position. So it's dead center on the project. Oh, let me do that. And I bought a bunch of these M3 screws just because they are useful for pretty much everything. And that's the reason why this thing has fins, those little protrusions, is because that will hold the LED ring off just enough so that those screws will not come into contact with it. And it also allows it to sort of cool. These rings can actually become warm. They are LEDs, so they don't use that much power, but what power they do use gets converted into heat. And if you have enough of that, eventually you'll actually start to melt 3D printed parts, which we don't want to do. That's never a good look. Okay, so this is going to go over the top, like so. Oh, you know what? Actually, this one has a little excess right there. Every once in a while, you can tell that these are cheap. Like so. All right, Megan, how you doing?
It's not working. I just need a pin, like a very hot pin.
I will help you in a bit.
No, it's okay. I'm just creating something else, I decided.
So what's it going to be?
It's an art project now. It's called frustration and mansplaining.
Oh, man. I was hoping to avoid that.
I wasn't talking about you.
Got it.
I was talking about Burke.
Burke. All right. So actually, what I should be doing right now is I should be doing the magnet, because the magnet is what makes this thing fun. Oh, These are rare earth magnets, so please don't mess with them. Oh, and by the way, if you hit these hard enough, they shatter, and then you get magnet dust. And let me tell you, magnet dust is horrible. Please don't breathe that, touch it, dream about it, think about it, talk about it.
It's so bad, don't even think about it.
Just leave it alone. Leave it alone. Are you stabbing things? You're like Miss Nancy on
I am
Romper
a child.
Room.
I am a 12-year-old boy.
Okay, you know what? Actually, let's switch projects.
Oh, good.
No, so what I need you to do is when this heats up enough, you're just going to put a thin bead of glue around the top just so that it maintains position. And I will fix yours really quickly. If you hand me your project. Thank you.
A thin bead of glue. Here, let me use my helping hands.
I see. I see what you got here.
Do you?
I do. I
don't
do.
need helping hands.
And I'm totally going to fix it for you. If you can hand me the solder pole. Thank you.
It's like an episode of Grey's Anatomy.
See, I never watched that. Do they do a lot of maker stuff on Grey's Anatomy?
They make bodies better.
There you go.
You did it with that thing?
Yep.
Burke was right?
No. Burke was never right.
Is this on?
Yeah, but it's got to heat up.
Oh.
Here you go.
Thank you. But what about this thing?
That's okay. I can fix that. I can fix that. I can.
Okay.
I can definitely fix that.
This Radio Shack glue gun leaves a little bit to be desired.
Oh my gosh, that is Radio Shack. So this thing that's like at least 20 years old. Yeah. Just on the inside, so you actually want it to touch the magnet?
The inside.
There you go.
What the? Oh my gosh.
You're filling it in. That's fine. It's hot glue. You can peel it off.
A thin bead.
That works. That works. That's perfect.
Here, take a look at that, Alex, before.
Look at that bad boy.
Look at that.
That magnet is most likely not going to move much places. All right. That's fine. And then I didn't put in the switches because that's, well, boring. But we're going to put this in just so you can see what the final assembly looks like before we have to end the show. And this is tight on purpose. Again, remember, there's only one position it can go in because it's slotted. But once it's in, it looks like this. Light up.
Are you ready for Gamora?
And this is what, once we get the ferrous material attached to Gamora, she's going to have her own little disco dancing floor.
Oh, that's nice.
Right? And it's going to be heavy enough that it won't be toppled over by any just little desk move.
And they're going to we're going to put them over your desk when you're gone. So the Gamora's desk will be, your old desk will be Gamora's desk.
And if you bring the lights back down, this is actually what it was really made for. That's right, folks. What did you call this before the show? This looks like radioactive urine? Mm-hmm. All right. Well, folks, I know that this was a lot of information, but we actually do have all the code, all the STLs, and yes, even step-by-step instructions so that you can assemble this. And by the way, Megan, you actually did a good job.
You keep saying actually.
Well, no. No, in the sense that, I mean, you don't solder.
No.
You don't. And for a person who doesn't solder, you were able to connect them. You know, we have to work on a couple of things, but this was, I hope, it was not a traumatic introduction to makery type stuff.
It's a good little barrette, isn't it?
That's what they're for. Now, if you want to know how to make one of these barrettes, what you want to do is you want to go to our show notes. Where do they find those, Megan?
They find those at twit.tv/KBOO. KH.
Right. There you're going to be able to find all of our back episodes, the notes for our back episodes, as well as a place to subscribe. If you want to, well, support the show, if you want to see more projects like this, if you want to see Megan and I just kind of messing around, then again, choose a video version, an audio version, or a high-definition video version, and everything will be cool. Now, you know what else is cool? Socials. I heard they do these things on the internet with the kids and the forums and stuff. You're going to find ours at Google+. Just go to Google+, look for Know-How, ask to join. Very short approval process. That's just how we keep out the spam accounts. But once you're in, you get access to almost 12,000 Kitas. Those are our know-it-alls. People at every stage of their maker journey. If you want to ask questions, maybe answer some questions, or post pictures of your projects so we can show them off here, again, just go to Google+ and look for Know-How. Of course, that's not the only place to find us. Megan, where do they find you?
I am on iOS Today, and that is every Tuesday morning with Leo. Tech News Weekly, which is every Thursday afternoon, just a couple hours if you're watching this live. Tomorrow, I'll be on Triangulation, interviewing Robert Underkoffler.
Oh, very nice. Yeah.
Who designed the thing for Minority Report, the gesturing. So I'm very excited
Which
about
we
that.
all want.
And then on Saturday, I will be on the new Screensavers with Leo, and we're going to be doing lots of fun stuff there, too.
Yeah. And where do they find you? On Twitter?
Oh, Megan Maroney, and at Megan Maroney, meganmaroney.com. On the website, I'm on Instagram at Megan Maroney. Really just Megan Maroney everything. I'm not very creative.
Just find Maroney. It'll be you.
Yes.
Yeah. And you're going to be able to find me at twitter.com/PadreSJ. Go there and follow if you want to see what I'm doing when I'm not at Twit, when I'm roaming around the world. In fact, in a couple of hours, I'll be back on a plane heading out of the country again, and you'll be able to find out what I'm doing if you follow me there. We also have a third member of our crew who we're not quite complete without him. He's a good guy.
It's not Burke.
It's not Burke, but because I said he was a good guy. But no, he's a good guy. He's kind of the black hole of despair, but that's why we love him. We call him Dr. Despair. You can find Dr. Despair where, again?
Excuse me. Oh, wait. I'm not even interrupting you. You can find me somewhere. I don't know. I'm sitting next to Burke.
Find him at twitter.com/ANEL.
Excuse me, Padre. That's pronounced Alex.
Oh, my goodness.
I haven't done this show in a few weeks.
Until next time, I'm Father Robert Balaser.
And I'm Megan Maroney.
And now that you know how,
Go take care of your Funko Pops. Don't funk them up.